Hi, today we discuss how to use trigonometric substitution in integration. From the word trigonometric substitution, we need first to understand some trigonometric identities. For the first one, we have 1 minus sine square equals cosine square theta. So we can use this property when we are trying to integrate, when the integrand have in the form of a squared minus x squared. And for the second identity, we have sine squared theta plus 1 is equivalent to secant squared theta, which can be used to integrate with the integrand x squared plus a squared. On the third one, we have secant squared theta minus 1 equals tangent squared theta, which can be used when the integrand have x squared minus a squared. So let's have a quick example. So our first integral is integral of 1 over square root of 4 minus x squared. Of course, we don't forget the dx. So what trigonometric identities we use here? And you see, we have in the first identity we have a squared minus x squared, and this integrand is in this form. So we need to use the first identity. Since we have a 4 in our integrand, we cannot use directly the first identity. So we do first, we factor out the 4 in the bottom. We have 4, 1 minus x squared over 4 dx. And we can write this integrand into, you can take out the 2 outside, so we have 1 over 2 square root of 1 minus, and you can write x squared over 4 as x over 2 squared dx. Since you have 2 here, you can actually put the 2 outside, okay, if you, okay. Now, so using 1 minus sine squared theta, and this is 1 minus something square, right? So we can let x over 2 as sine theta. Okay, so we need to take derivative both sides, so this will give you dx over 2 equals derivative sine is cosine d theta. So that makes dx equals 2 cosine theta d theta. Okay, now we can that means we can write this integral into 1/2 integral of 1 over 1 minus, the x over 2 become just sine, and there's a square there, so 1 minus sine squared theta. This one is under still square. Okay, now your dx is equivalent to 2 times the cosine theta d theta. And as you notice here, we can just actually cancel out the 2 and the 2 here. Now we have 1 minus sine square, which is equivalent to cosine square. So this integral is actually equivalent to 1 over square root of cosine square theta. We have also cosine theta on the top. And as you notice here, you can just actually cancel the radical and the square. And after that, you can actually cancel with the cosine. So we're left with the integral of just 1 d theta or d theta. In theta word, integral of d theta is actually just x or theta. Since we want our original integral is about x, so we need to convert this one to the x variable. And we need to go back to our substitution, which is x over 2 being equivalent to sine theta. And so how to find theta in this equation? So we have x over 2 equals sine theta, right? So of course, if you want to find the sine theta, we just do the inverse sine both sides. So theta would be the inverse sine, or sine to the negative 1 over 2. Okay, so our answer will be the inverse sine x over 2 okay, plus c. So this is our answer to our integral. Okay, our second example is we have integral of square root of x squared minus 9 over x over 4. Okay, don't forget the dx. Okay, so what form do we have here? So can we use a squared minus x squared? So this form is x squared minus 9, right? So we must use the third one, the second squared theta minus 1, which is because we have x squared minus a squared. So somehow we need to use the second squared theta minus 1 in our substitution. And again, we cannot use that directly because we have a 9 in the radical. So we need to factor out 9 first. So if you factor out 9, we get 9 x squared over 9 there minus 1 over x to the fourth. Okay, then 9 can be taken out, so you have 3 there, radical. Okay, the x squared over 9 can be rewritten as parentheses x over 3 squared minus 1, then x to the fourth dx. Okay, so we have something square minus 1, right? So that means we can convert this one into, by letting x cubed over 3 into second theta. Okay, by letting x over 3 equivalent to second theta, the whole radical inside the radical will be in this form. Okay, so okay, now we need to take derivative. So dx over 3 is equivalent to, the derivative of second theta is the secant. Okay, then we have d theta. Okay, that makes dx equivalent to 3 times secant theta tangent theta. Okay, so let's convert this integral into theta world. So we have integral of 3 there, square root of, now the x over 3 square become just secant square theta minus 1. Then okay, I think we have x over 4 there. Our x is equivalent to 3 secant theta, right? By multiplying 3. So if you raise this one to the power of 4, you get 3 to the 4th, which is 81. Secant to the 4th power theta. Then your dx is equivalent to 3 times secant theta tangent theta d theta. Okay, what can we do from here? Okay, first we know this one is secant squared theta minus 1 is tangent square, right? And you take square root of that, so we get yeah, we just the radical just left with the tangent, right? And you see here we can cancel that with 3 and 81, so that's 1 over 27, right? Okay, so oops, there's one more, so we can this is 3 times 3 9, so this is actually just 9. Okay, you can cancel out with 9 here. Okay, the secant to the 4th power, we cancel out with the secant in the top, so become just secant cube theta, and the tangent tangent here become just multiply with the tangent, so we have tangent square theta d theta. Okay, so that's the simplified version. So we can rewrite this one a little bit. So we know the property for second 1 over second cube is cosine, right? So we have integral of, so we can put the 1 over 9 in the front. So we have tangent square. The second cube become the top, so we have second cube. Okay. So it's kind of a little bit. Oops, sorry. This is cosine. Okay, so we can convert tangent theta into sine over cos. So let me convert first. So tangent square is equivalent to sine square over cosine square. Then you have cosine cube there. And you see we can cancel out this one, left with the cosine theta. So we have sine square theta and cosine theta, d theta. Okay. So from here we can use another substitution by letting u equals the sine theta. Okay, that means du is cosine theta, d theta, right? So we have cosine, so this one is just equivalent to du, right? So we have 1 over 9 integral of, so the sine square becomes just u square by substitution. And the cosine theta, d theta become the r du, right? So, and this one is u square, and integrate that one. So we have 1 over 9 u cube over 3. Okay, that's multiplying. Okay, so this one can be rewritten into u cube over 27. But we're trying to integrate in terms of x, right? So we need to return our variables. So first, so we know u is sine theta, right? So this one is given to sine cube, okay, using this substitution. So u cube is sine cube theta over 27. And theta, of course, is not yet in x, right? So we need to refer on our first substitution, which is this one. So this is x over 3 secant theta, right? So we need to use our triangle concept of right triangle. So this is the theta, and you know secant theta, right, is hypotenuse over adjacent. So yeah, hypotenuse adjacent, that represents x is the hypotenuse, so x is the hypotenuse, right? Hypotenuse of the adjacent, and the over is 3, so the adjacent will be 3 with respect to theta. So using Pythagorean theorem, and I believe you know this one will be square root of the hypotenuse square minus adjacent square, which is 9. Okay. So that means sine cube theta will be, yeah, the sine theta is equivalent, let's find the sine theta first. So sine theta with respect, yeah, using this triangle, we have square root of x squared over 9, square root of x squared minus 9 over x, right? Opposite over hypotenuse. So we're almost done. Sine cube, so we just cube this sine. So our answer would be square root of x squared minus 9 over x cube. Then you have divided by 27. Okay, you can rewrite this one into okay, It's better to write, because radical is same as half power, right? So you can just write this one into x squared minus 9, 3 halves, okay? And you have x cubed there over 27. So we have dividing 27, so basically this one kind of a flip. Okay, so we have our final answer. And we don't forget the plus c. And this is our final answer to our integral.